Rockwell B-1 Lancer, supersonic strategic heavy bomber. The Rockwell B-1 Lancer is a supersonic variable sweep-wing, heavy bomber used by the United States Air Force. It is commonly called the and quat, bone and quat, from and quat, B-1 and quat winking face. It is one of 3 strategic bombers serving in the U.S. Air Force fleet along with the B-2 Spirit and the B-52 Stratofortress as of 2022. The Boeing B-1B Lancers joined service in 1985, supporting troops in Iraq, Afghanistan, providing air support to ground troops. Originally designed for nuclear capabilities, the B-1 switched to an exclusively conventional combat role in the mid-1990s. Pilots call it the bone, not because it looks like some anatomical part, but because people like to give meaning to otherwise seemingly random designations. Its official name is B-1 Lancer, and its trade is heavy bombing enemy positions. The B-1, aka B-1, like most other planes currently flying, is an old beast. An icon of the latter decades of the Cold War, the B-1B Lancer was originally designed as a strategic nuclear bomber with a mission to fly at low altitude in order to avoid Soviet early warning radars. With the end of the Cold War, the B-1B Lancer has been adapted to carry conventional munitions and has been used extensively in close air support and tactical bombing missions. The B-1 was first envisioned in the 1960s as a platform that would combine the Mach 2 speed of the B-58 Hustler with the range and payload of the B-52, and was meant to ultimately replace both bombers. After a long series of studies, Rockwell International, now part of Boeing, won the design contest for what emerged as the B-1A. This version had a top speed of Mach 2.2 at high altitude and the capability of flying for long distances at Mach 0.85 at very low altitudes. The combination of the high cost of the aircraft, the introduction of the AGM-86 cruise missile that flew the same basic speed and distance, and early work on the stealth bomber all significantly reduced the need for the B-1. This led to the program being cancelled in 1977, after the B-1A prototypes had been built. The program was restarted in 1981, largely as an interim measure due to delays in the B-2 stealth bomber program. This led to a redesign as the B-1B, which differed from the B-1A by having a lower top speed of Mach 1.25 at high altitude, but improved the low-altitude speed to Mach 0.96. The electronics were also extensively improved, and the airframe was improved to allow takeoff with the maximum possible fuel and weapons load. Deliveries of the B-1B began in 1986 and formally entered service with Strategic Air Command (SAC) as a nuclear bomber that same year. By 1988, all 100 aircraft had been delivered. The B-1B is a multi-role, long-range bomber, capable of flying intercontinental missions without refueling, then penetrating present and predicted sophisticated enemy defenses. It can perform a variety of missions, including that of a conventional weapons carrier for theater operations. Through 1991, the B-1 was dedicated to the nuclear deterrence role as part of the Single Integrated Operational Plan, SIOP. The B-1B's electronic jamming equipment, infrared countermeasures, radar location and warning systems complement its low radar cross-section and form an integrated defense system for the aircraft. The swing wing design and turbofan engines not only provide greater range and high speed at low levels, but they also enhance the bomber's survivability. Wing sweep at the full forward position allows a short takeoff roll and a fast base escape profile for airfields under attack. Once airborne, the wings are positioned for maximum cruise distance or high-speed penetration. The B-1B holds several world records for speed, payload, and distance. The National Aeronautic Association recognized the B-1B for completing one of the 10 most memorable record flights for 1994. The B-1B uses radar and inertial navigation equipment, enabling aircrews to globally navigate, update mission profiles and target coordinates in flight, and precision bomb without the need for ground-based navigation aids. Included in the B-1B offensive avionics are modular electronics that allow maintenance personnel to precisely identify technical difficulties and replace avionics components in a fast, efficient manner on the ground. The aircraft's an ALQ-161, a defensive avionics is a comprehensive electronic countermeasures package that detects and counters enemy radar threats. It also has the capability to detect and counter missiles attacking from the rear. It defends the aircraft by applying the appropriate countermeasures, such as electronic jamming or dispensing expendable chaff and flares. Similar to the offensive avionics, the defensive suite has a reprogrammable design that allows in-flight changes to be made to counter new or changing threats. Carrying the largest payload of both guided and unguided weapons in the Air Force inventory, the multi-mission B-1 is the backbone of America's long-range bomber force. It can rapidly deliver massive quantities of precision and non-precision weapons anywhere in the world. The B-1B's blended wing body configuration, variable geometry wings and turbofan afterburning engines, combine to provide long-range maneuverability and high speed while enhancing survivability. Forward wing settings are used for takeoff, landings, air refueling and in some high-altitude weapons employment scenarios. Aft wing sweep settings, the main combat configuration, are typically used during high subsonic and supersonic flight, enhancing the B-1B's maneuverability in the low and high altitude regimes. The B-1B's speed and handling characteristics allow it to seamlessly integrate in mixed force packages. These capabilities, when combined with its substantial payload, excellent radar targeting system, long loiter time and survivability, make the B-1B a key element of any joint, composite strike force. The B-1 is a highly versatile, multi-mission weapon system. The B-1B's synthetic aperture radar is capable of tracking, targeting and engaging moving vehicles as well as self-targeting and terrain-following modes. In addition, an extremely accurate global positioning system aided inertial navigation system enables aircrews to navigate without the aid of ground-based navigation aids as well as engage targets with a high level of precision. The Combat Track 2 radios provide a secure beyond line-of-sight reach-back connectivity until Link 16 is integrated on the aircraft. In a time-sensitive targeting environment, the aircrew can use targeting data from the Combined Air Operations Center over Combat Track 2, then to strike emerging targets rapidly and efficiently. This capability was effectively demonstrated during Operations Enduring Freedom and Iraqi Freedom. The B-1B's onboard self-protection electronic jamming equipment, radar warning receiver, ALQ-161, and expendable countermeasures, chaff and flare, system and a towed decoy system, AL-50. Complements its low radar cross-section to form an integrated, robust defense system that supports penetration of hostile airspace. The ALQ-161 electronic countermeasures system detects and identifies the full spectrum of adversary threat emitters, then applies the appropriate jamming technique either automatically or through operator inputs. Current modifications build on this foundation. Radar sustainability and capability upgrades will provide a more reliable system and may be upgraded in the future to include an ultra-high resolution capability and automatic target recognition. The addition of a fully integrated data link, or FIDL, will add Link 16 communications capability. FIDL combined with associated cockpit upgrades will provide the crew with a much more flexible, integrated cockpit, and will allow the B-1 to operate in the fast-paced integrated battlefield of the future. Several obsolete and hard-to-maintain electronic systems are also being replaced to improve aircraft reliability. The B-1A was initially developed in the 1970s as a replacement for the B-52. 4 prototypes of this long-range, high-speed, Mach 2.2, strategic bomber were developed and tested in the mid-1970s, but the program was cancelled in 1977 before going into production. Flight testing continued through 1981. The B-1B is an improved variant, initiated by the Reagan administration in 1981. Major changes included the addition of additional structure to increase payload by 74,000 pounds, an improved radar and reduction of the radar cross section by an order of magnitude. The inlet was extensively modified as part of this RCS reduction, necessitating a reduction in maximum speed to Mach 1.2. The first production B-1 flew in October 1984, and the first B-1B was delivered to Dyess Air Force Base, Texas, in June 1985. Initial operational capability was achieved on October 1, 1986. The final B-1B was delivered May 2, 1988. The B-1B holds almost 50 world records for speed, payload, range, and time of climb in its class. The National Aeronautic Association recognized the B-1B for completing one of the 10 most memorable record flights for 1994. The most recent records were made official in 2004. The B-1B was first used in combat in support of operations against Iraq during Operation Desert Fox in December 1998. In 1999, 6 B-1s were used in Operation Allied Force, delivering more than 20% of the total ordnance while flying less than 2% of the combat sorties. During the first 6 months of Operation Enduring Freedom, 8 B-1s dropped nearly 40% of the total tonnage delivered by coalition air forces. This included nearly 3,900 JDAMs, or 67% of the total. In Operation Iraqi Freedom, the aircraft has flown less 1% of the combat missions while delivering 43% of the JDAMs used. The B-1 has a blended wing-body configuration, with variable sweep wing, 4 turbofan engines, triangular ride control fins and cruciform tail. The wings can sweep from 15 degrees to 67.5 degrees, full forward to full sweep. Forward swept wing settings are used for takeoff, landings and high-altitude economical cruise. Aft swept wing settings are used in high subsonic and supersonic flight. The B-1's variable sweep wings and thrust-to-weight ratio provide it with improved takeoff performance, allowing it to use shorter runways than previous bombers. The length of the aircraft presented a flexing problem due to air turbulence at low altitude. To alleviate this, Rockwell included small triangular fin control surfaces or vanes near the nose on the B-1. The B-1's structural mode control system moves the vanes, and lower rudder, to counteract the effects of turbulence and smooth out the ride. Unlike the B-1A, the B-1B cannot reach Mach 2 speeds. Its maximum speed is Mach 1.25, about 950 miles per hour or 1,530 kilometers per hour at altitude, but its low-level speed increased to Mach 0.92, 700 miles per hour, 1,130 kilometers per hour. The speed of the current version of the aircraft is limited by the need to avoid damage to its structure and air intakes. To help lower its RCS, the B-1B uses serpentine air intake ducts and fixed intake ramps, which limit its speed compared to the B-1A. Vanes in the intake ducts serve to deflect and shield radar returns from the highly reflective engine compressor blades. The B-1's main computer is the IBM AP-101, which was also used on the Space Shuttle orbiter and the B-52 bomber. The computer is programmed with the Jovial programming language. The Lancer's offensive avionics include the Westinghouse, now Northrop Grumman, and APQ-164 forward-looking offensive passive electronically scanned array radar set with electronic beam steering, and a fixed antenna pointed downward for reduced radar observability, synthetic aperture radar, ground-moving target indication, GMTI, and terrain-following radar modes, Doppler, navigation, radar altimeter, and an inertial navigation suite. The B-1B Block D upgrade added a global positioning system, GPS, receiver beginning in 1995. The B-1's defensive electronics include the Eaton and ALQ-161A radar warning and defensive jamming equipment, which has 3 sets of antennas, one at the front base of each wing and the third rear-facing in the tail radome. Also in the tail radome is the AN ALQ-153 missile approach warning system, pulse Doppler radar. The ALQ-161 is linked to a total of 8 and AL-49 flare dispensers located on top behind the canopy, which are handled by the AN ASQ-184 avionics management system. Each AN AL-49 dispenser has a capacity of 12 MJU-23A, B flares. The MJU-23A, B flare is one of the world's largest infrared countermeasure flares at a weight of over 3.3 pounds, 1.5 kilograms. The B-1 has also been equipped to carry the AL-50 towed decoy system. Beginning in 2014, the B-1 was used against the Islamic State, IS, in the Syrian civil war. From August 2014 to January 2015, the B-1 accounted for 8% of USAF sorties. During Operation Inherent Resolve, the 9th Bomb Squadron was deployed to Qatar in July 2014 to support missions in Afghanistan, but when the air campaign against IS began on 8 August, the aircraft were employed in Iraq. During the Battle of Kobani in Syria, the squadron's B-1s dropped 660 bombs over 5 months in support of Kurdish forces defending the city. This amounted to 1/3 of all bombs used during OIR during the period, and they killed some 1,000 ISIL fighters. The 9th Bomb Squadron's B-1s went and Quat, Winchester and Quat, dropping all weapons on board 31 times during their deployment. They dropped over 2,000 JDAMs during the 6-month rotation. B-1s from the 28th Bomb Wing flew 490 sorties where they dropped 3,800 munitions on 3,700 targets during a 6-month deployment. In February 2016, the B-1s were sent back to the U.S. for cockpit upgrades.